Okay, this afternoon, Lieutenant Colonel Thyra, I want to make sure I pronounce it correctly, Thyra Bishop of the Oregon Air National Guard. Ms. Bishop studied atmospheric science in the last undergraduate class offered at Oregon State University on a military ROTC scholarship. Upon the award of her degree, she entered active duty as a meteorologist working with military airlift, air combat systems, reconnaissance aircraft, and army units. She has combat medals from Desert Storm and Afghanistan. Her awards include Defense Meritorious Service Medal, Air Force Meritorious Service Medal, Army Commendation Medal, and Air Force Commendation Medal. Lieutenant Colonel Bishop is currently serving with the 142nd Fighter Wing at the Portland International Airport, Oregon Air National Guard. Ladies and gentlemen, please welcome Thyra Bishop.
Thank you. Bob, can you hear me? Bob can hear me, so I know you can hear me. Yes, I'm Colonel Bishop. First, I want to recognize a weather hero. Captain Nathan Nylander was a meteorologist for Davis-Motham's 25th OWS. He was serving in Afghanistan, and on April 27th, he was in a conference when a gunman opened fire. Captain Nylander evacuated the room and went and engaged the gunman. He fired his pistol, thought he had subdued the gunman, however the gunman returned fire, and Captain Nylander died. For this, Captain Nylander did receive a Silver Star for evacuating the room. So I want to recognize Captain Nylander, Silver Star this year. Again, I've worked with the Air Force with C-5s, 141s. This is an AC-130, one of my favorite airplanes, but I haven't worked with them. I have worked with a C-130, WC-130 I have not worked with. There are Hurricane Hunters, A-10s, very cool. U-2s, yes, I've worked with those. F-16s, B-52s, our own F-15s out here at Portland Air National Guard. The 41st Brigade Combat Team, as well as the 82nd and the 101st, and I do have combat medals. The history of weather in the United States actually starts with the military. It actually started with people going to Congress and saying, Congress, there's this big storm, do something about it. And Congress did. They decided to send meteorologists or observer sergeants to the west of the Great Lakes in the forts they already had, and have those observer sergeants let the Great Lakes know there's a storm coming. And what I love is the fact that these observer sergeants, they were to give the forecasts, and the first name for the National Weather Service was the Division of Telegrams and Reports for the Benefits of Commerce. But that's it. Weather warnings and advisories still are bread and butter. At first they started out with 24 stations, but 8 years later they were all the way up to 284 stations, and we were talking about pressure. One of the observations was pressure of wind in pounds per square foot, probably for the sailing vessels at the time. Now you got all these observers, and there was a problem with something called the Rocky Mountain locust, so they said, Sergeant, should the Rocky Mountain locust appear in or near your area, please give this observation. And so we observe a lot of things in the military. Oh. By 1937, we knew war was coming. That was pretty obvious. So the Army Air Corps Weather Service was formed. And by 1947, after the war, the Air Force split out of the Army, and we ended up with the Air Weather Service. Now, the Army got veterinarians, the Air Force got meteorologists, so you get this poor guy, just enlisted. What do you mean I have to go to Fort Bragg? I'm in the Air Force. Yes, you are. Okay, everybody wants to hear about the D-Day forecast, right? D-Day, September 4th, 1943. The location, this is the Pacific region. General George C. Kenney, he was in charge of the 5th Air Force out in the Pacific under General MacArthur. The area we're going to fight is Papua New Guinea. This is where the 41st Division actually fought during World War II, Oregon Zone. Now, the tactical situation is this. We got to get the Australians and the Americans here at Leh. There's a huge Japanese base at Rabaul and a large Japanese base at Wewak. And General Kenney knows he doesn't have the Army Air Corps aircraft to take on both those forces. They're really large. But his meteorologist told him, there's this cloud cover that comes in at the first week of September for 2 or 3 days. It's going to cover that one base at Rabaul, and all you're going to have to worry about is the base at Wewak. Also, if you continue to hit Wewak with bombs, the Japanese are going to have no idea where you're going to land. So literally, General Kenny says to General MacArthur, our long-range weather forecasters should be able to predict such weather 3 days in advance. Let them decide the best day to go in, and we can keep the whole schedule flexible enough to take advantage of nature's help. General MacArthur said that it looked as though the infantry had lost their last prerogative. Up till that time, at least the infantry had the right to decide the date and hour of their attack. Now, we were about to turn that privilege over to an Air Force weatherman. But he agreed that it did sound plausible, and General Kenny put 2 teams on, an Australian team and an Air Force team. Now, what do you get when you get 2 forecasters? At least 3 forecasts. Well, by the 29th of August, the forecasters were saying September 4th. But the next day, the Americans went with one date, and the Australians went with a different. The story got around General Headquarters that the weather boys were all tangled up, and people were beginning to whisper about General Kenny's screwy ideas. On the morning of September 1st, however, the teams were still apart, but by midnight that night, they were able to give the one forecast. All this time, the B-25s were bombing Wewak and doing what they needed to do in order to prepare for the attack. By midnight, the 2 weather teams had come to an agreement, said September 4th he would have the ideal weather for the attack. However, in the afternoon, the Japanese would be able to counterattack. And that's exactly what happened. The Australians were able to come in. A couple of Japanese were able to fight under the cover, but then the American team was able to land the next day. So here we have the Australians coming in to the beach there, coming in while the Americans land and then come inland. That's the 503rd. And here are different images from those particular battles. These are the Japanese airplanes that were taken out at Wewak. B-25 preparing attacks. The Australians being able to land rather safely there at the Hopai Beach before they went over to Lae. This is a great image. These are the P-47 transport airplanes that the paratroopers are going to come out of. And in the corner, that's General MacArthur and General Kenny. General MacArthur is the taller of the 2 men. And here's the actual paratroop job into NASDAQ that day. So somebody was asking about using weather practically. Well, when it comes to military weather, we are all about how is weather going to impact you. For some reason, a general really doesn't give a darn about what's happening with the 500 millibar analysis. He wants to know, can his troops get in? Another funny thing I noticed is when you look at the different levels of weather, they correlate with the different levels of war. You've got your strategic level where we're talking about nations and maybe things taking a few years. Well, we have our climate products and our global weather products that come out of the Air Weather Service or the Air Force Weather Agency now. At the operational level, now we're looking at, a year to maybe months time frame. And the tactical level, our generals want to know what's happening within that week. Anything beyond that's a bit much. So at our global weather, we have our climate and our model data. The operational level, we are looking at fairly large areas where weather is taking place. And then our tactical level, we are down there in the weeds with the operators. Here I am with the Oregon National Guard. Lieutenant Colonel Matt Doggett's with me as well. We do support the Air National Guard troops here, the Army National Guard. We have a special unit for our Special Tactics Squadron. They are the Gray Berets. We support state agencies in case there's a natural emergency, and if there are natural disasters, we go out and we help with that as well. As a combat weather team, when we go overseas, we are the eyes forward. We are the ones taking the observations and working with the commanders on the ground. Our weather forecasts are sent back to our operational weather squadrons. Our data goes back to them, but they actually do the warnings, advisories, and forecasts so that we can actually take the data and tailor it and let the commanders know how it's going to impact them. So how do I do that specifically? Okay, this is what happens. It's the afternoon, and the air tasking order comes out. This order comes down to all the individual units, and it tells them how every aircraft is going to work the next day. Well, I don't really care too much about every other aircraft. I want to see what my F-15s are doing. And I see that they're going to be doing 2-ship patrols in these different grids. I'm also going to look at things that will impact that on the ground as well as the air refueling. Those are what I'm looking at. That's my part of the war. I then work with the intelligence officer as well as the operations officer, and we try to figure out how weather is going to impact them so that they can do the best planning they can within the next 24 hours for the battle to come. So here are the grids we're going to fly. Now, I wasn't exactly sure what enemy I could have, so I went ahead and I put a little pirate flag there. We can all agree pirates are evil, so there's my pirate flag. And I'm looking at this, and well, gosh, the forecast, they're right there in that river valley, and in the morning they're going to have valley fog until about 10:30. Great, we don't have to really worry about them flying. And in the afternoon, oh look, we're looking at some thunderstorms. That's going to impact. This is a very broad way of saying these are the impacts that you're going to see so that they can plan weather into what they're doing. And again, what we're trying to do is work closely with the commanders to let the commanders and the pilots know how is weather going to impact you. Now I can have Colonel Matthew Doggett come up and talk to us about the Army support. Colonel Doggett's been with I met Colonel Doggett here, October 2001. 10 years ago, and he said, wow, we've got military weather people? I'm all for that, because he had just left active duty. So, Colonel Doggett, you want to introduce yourself and say hi?
Yeah, so as Thyra said, it's been 10 years now I've been with the Oregon Air Guard. That's after about 8 years of active duty experience doing the same thing, doing a weather officer. Graduate out of UW, former student under Cliff Mass there, and so it's kind of come all the way back around to the Northwest about 10 years ago. Thyra did a good job describing the air component side of weather operations. My job is commanding the combat weather team is the Army side. She said when the Army Air Corps broke off into the Air Force in '47, they took all the weathermen with them. And the Army said, hey, wait a minute, not so fast, we need those guys too. And so the Air Force agreed to provide all the weather support for the Army. And so there is a component of the Air Force that is assigned to do just that and provide the Army all their weather operations. Rather than the big sky picture of what's happening up above, say 10,000 feet, the Army is all about what's happening on the ground. They need to know impacts as to how much rain is going to fall. Is it going to make the ground muddy, where it's going to stop their tanks, or is it going to be too foggy? They're not going to be able to see the enemy or reconnaissance in their helicopters. They're not going to see any of the bad guys, or they maybe take advantage of the fog. Those kind of things. So they're real interested about the no kidding, the so what. What does that tell me? They don't want the weather guy to stand up and say, foggy tomorrow, sir. The boss is going to say, yeah, so what? And then you can turn around and say, well, it's going to hide the bad guys and they're going to move around and you won't be able to get to them. And then at which point the boss says, oh, I need to come up with a plan B then. So that's the important side of the Army side. My experience has been, I've been deployed to Iraq twice, and have done a lot of the tactical level support. One of the more interesting things, so this is a snapshot of some of our guys in the field setting up some that was called the TMQ-53. That's the tactical meteorological equipment. Basically, it's a lightweight portable version of an ASOS, effectively. And so we're able to set that up and provides all digital automated observation gathering ability, and to do it remotely and largely unattended. And so there's an image in there in operation. Of course, helicopter operations are the primary method that the Army takes to the air. And so there's a lot of impacts that weather can have on the helicopters. And so they get to know us pretty well, and we get to know them. Take an observation. Again, as Thyra said, the core of our forecasting capability really is collected into the operational weather squadrons. The centers at Davis-Monthan, or Scott Air Force Base, or Shaw Air Force Base, South Carolina, Ramstein in Germany. These major centers where they will pull 150, 200 weather guys together. They've got FAT communications. They've got a lot of expertise. They're the ones that do the bulk of the forecasting, and they push that out into the field where the guys in the field are out doing this kind of stuff, gathering the observations, while the guys in the centers are doing this kind of stuff, and gathering all the model data and trying to collect it into a forecast. They push it back out, and then the guy in the ground then has to take the weather forecast that's put out, the 500 millibar charts or whatever, and turn that into something that an Army commander is going to want to hear. Another interesting component I saw my last time I was in Iraq last year was as the senior meteorologist for all of Iraq operations, weather operations. And the position that put me in was a little more unique in that we're starting to get interested in not so much the combat side of things, but the civilian and nation capability. Because well, it's obvious we're not going to be there forever, and effectively we need to get them going so they can pull their own weight. And one of the unique things that I was able to be involved in is the very first group of Iraqi forecasters for their brand new, never had before, Iraqi Air Force Weather Service. And so we graduated their first class in April of 2010, their first class of meteorologists. And so now they have the capability to support their own Air Force in their own operations and help to protect them from the elements, as it were. So that was kind of interesting. And the other thing as well, someone also said, well, the military doesn't run the airports, the civilians do. What are they doing to get the airport civil capacity back up and running? And so I spent a fair amount of time in Baghdad on the civilian side, outside the base, working with the IMO, the Iraqi Meteorological Organization. Actually, once upon a time, a very proud and robust meteorological capability that got severely impacted, as you can imagine, in '91 with the first round of war, and then again in '03 with the second round. So they've been pretty much hamstrung for the last 20 years to be able to do what they've been trained to do, and frankly, they're very proud of doing. And it's interesting. Some of the cultural things come down when you start communicating meteorology. It's a universal kind of a thing, and some of the same problems and issues that they have, are the same things that we've encountered. One interesting story was when they understood the bombs are starting to fall on their, and what gets impacted are, the airports, which happen to be close to the military targets. The observers and the forecasters, basically, they gathered all the records that were in the weather station and took them home with them, because they knew if they left them there, they would get, looted, destroyed, burned, whatever. So I think it was kind of a testament to the professionalism and the pride of the weather services there. And now in 2010, we were able to get them back, get open up the communications again between them and the WMO, and to get them some more support in helping to resurrect their services. They were getting a radar put in there west of Baghdad. They were getting some ASOS equivalent weather stations reinstalled at the airports. And so it was interesting to be a part of that and to help, in some sense, facilitate that, which is a very different role than the combat side of things, where we're good at blowing things up, and sometimes we're not so good about putting things back together again. And so we were trying to fix some of that and make sure that they were left in a position where they could really start moving forward. So that was some the interesting experience. The other thing is, when talking about impacts, we had there was a Corps of Engineers fellow here, and he talked about rivers, and the same thing happened with in the combat area that Iraq was. There was the Army Corps had numerous temporary bridges, and I found myself in a position where they would, during the winter times, quite heavy rains would happen in the mountainous rugged terrain, and lo and behold, 3 days later, their temporary bridges, which they have set up for river height X, now it's Z, and find themselves underwater, and so being able to communicate that, look, these are the impacts of a heavy rain event, and coming up with the means to communicate that to the Army Corps types that were there, and providing that advanced warning so they could then shore up their bridges and prevent them from washing away. And some other pictures of showing them our equipment, the things that we use in the field there. So yeah, and then there's the third aspect of Air Force weather support is the special operations side. Yeah, we'd have pictures, but unfortunately we would.
We couldn't get them to help. We do have six slots for our gray braids.
So the third component is the special operations side, and these are very specialty trained. They're meteorologist trained, but they're trained in all other aspects of some of the more unique side of military operations. Driving helicopters, skiing, snorkeling. All those kind of jumping out of airplanes at high altitude or low altitude and all kinds of conditions, and being able to operate in remote, unsupported locations. Yeah, their training pipeline is about 2 years worth of, and it's a little bit of weather and a whole lot of everything else. And because they are part of a small, like 4 or 6 man team that goes out in what we call very restricted environments, aka behind enemy lines, so to speak, and work in an environment and then report back. So their weather expertise is to be able to report back that weather intelligence to folks outside and be able to facilitate. Well, maybe they're going to do paratroop drops back in there, or there's going to be a UAV mission somewhere, and they need to be able to know, are they going to be able to see the target or whatever, and they can relay that information back in. Because quite frankly, in the places where we tend to fight wars, there's not a lot of data or information. So is that it? So that's
I've got pictures. That's a tactical guy with a big red balloon that he's about to let off. And then just, the last thing we do is we do solar forecasting, which actually a lot of our customers are interested in how the sun's going to impact them. So that's a big part. That's it.
So thank you very much, Ms. Bishop. Wow, impressive. Thank you.